Okay, in this lesson, we're going to learn about arithmetic and geometric sequences and series word problems. You're supposed to clap. You guys suck. Okay, thank you. I normally clap to myself during lessons, but you can't hear it. So here's our formulas that we've learned so far, and these are ones I actually don't always have these memorized because I only do this one chapter a year. And so you will be given these on a test, and they're not expected to be memorized because they're just the first time you're learning them. So you'll kind of keep those in here, okay? So take a look at number 1. We're going to be using some of these formulas throughout all of them. So it says a woman made $35,000 during the first year of her job. Each year she received a 10% raise. Is that likely? No? You don't think? Is that a crazy raise? Would there be professions where they do receive a 10% raise? Probably, right? A doctor, you think? Basketball player. If they perform. Most don't. It'd be the rare ones who are like the top 10. Yes. One of the things that you should know when you're looking at your careers is it's oftentimes entry-level jobs are very low paying. So when you do your first year in the job after you get done with college, you're going to have an entry-level job that's going to pay you lower. Okay, sorry, we hit pause. So if you start out low, like I will say, for example, I hope she doesn't watch this video ever, but my sister-in-law, when she got done with her degree at Winona State, she was a waitress and then got a job in her degree. And so she was making like $30,000 a year waitressing, working now 60-hour weeks, right? Not 40-hour weeks, weekends, no health insurance, no retirement, but making like $30,000 a year. So that seemed like a lot of money to her when she was 22. It did. She had an entry-level job offer in her degree, her 4-year degree, was like $24,000 the first year. Guess what she chose to do? Waitress, because she made more money. The degree job, the $24,000 a year, was a pay cut, technically, right? But she would have made more. I mean, she would get much bigger raises there than a waitress, and she probably makes the same now, doesn't she? In fact, maybe lower because the economy's not very good. And so what she did is she didn't take that job, where that job would have had retirement, benefits, all of those things that matter at her age now and wouldn't have mattered as much when she was 22. She wasn't married, didn't have kids, figured she'd be healthy forever, right, because you're 22. Now she's 31, and guess what she does? She's a waitress, and she has been so long out of her degree, she can't get a job in that degree because she's been out of the field for 10 years and never really been in the field. So her 4-year degree is almost useless. She'd have to go back to school for anyone to hire her, because why would you choose her over someone who just got their degree, right? She has 2 kids, works every evening and every weekend, so when her kids go to school, will she ever see her children? No. So do you see, and I'm not saying that a waitressing is a bad job. I'm saying when she was given that choice, she maybe didn't make the best choice, in my opinion, right? Do you see, and would she be making more than $30,000 a year now? Oh yeah, she would be, for sure, in her career if you look at the growth. So those are things you should think about. So when we do these problems, that's stuff that can apply to how you will do your jobs when you guys get done with school or high school, whenever you decide to go into the workforce. So back to our problem. This is what I don't do on videos. Don't you appreciate that I don't ramble on and on forever? Thank you, Tom. Okay, each year she received 10% raise. How much did she earn in her 10th year in the job? So would this be considered arithmetic or geometric? Why? Arithmetic would be if she got what raise every year? Is a 10% raise the same every year? No. Hopefully you're saying no. Why? You times it by 10%, don't you? So if they said she got a $500 raise every year, that'd be arithmetic, wouldn't it? So we're in geometric. So we're going to use our geometric formula, and we're looking for her earnings after 10 years. So we're going to say after the 10th year, what did she start with? What's her first term? Oops, I'm on B, sorry. We're on A here. How much did she make her first year? $35,000. And then if you look at your formula, we have an R. What would be our rate here? If she's going up 10% every year, how much of her salary does she make? Is it just 0.1? What'd you say, Casey? 1.1. She makes 100% of that 35,000 plus an additional 10%. So our rate is 1.1. And then our time, they asked how much does she earn in her 10th year on the job. So our n is 10. So n minus 1 is 10 minus 1. So now on your calculator, take 1.1 to the 9th. And then times that by 35,000 and tell me how much money she'd make in her 10th year on the job. Anybody? That's not what I got. I got 82,000. Yeah? $82,528.17? Double check that. Okay. So is that decent salary after 10 years in the job? Oh yeah, I can tell you after 10 years of teaching there's no way I went up that much, right? I don't think anyone in the job. You go home to your parents, they probably didn't go up that much on their job. Maybe one person in here. And they would all be very happy that happened to them. Now, B, what were her total earnings during her first 10 years in the job? So what are they looking for here? They want us to add all of them up, the summation, right? So we're going to use our summation formula. Do you want to use, can I use this one from our calculator? You okay with that one? So we're looking for year what to what? Her first year to her 10th year. And then when I plug that into the formula, we have 35,000 times our R, and then to the n minus 1. Even though we know that this is a 10, always, 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 you leave it an n in your formula when you're punching in your calculator. So go to your calculator, punch that in. If you haven't watched this video, you have no idea how to do that. Should we all do it together? Oh, you guys are no fun. Why not? Let's do it. So, on your calculator right now, you're going to go to Math and 0. It's right after the 9. So you'll see that it has all that good stuff there. So right now you have a blank right here, a blank right here, a blank right here, and then you have this, right? That's the summation symbol, which you learned about in the previous video. We'll use an X. So let's use an X instead of an N. You could put an N in, but we'll just use an X. The variable doesn't matter. Yours doesn't have, I'll look for yours. And then it arrows to the next one, so then you'll put a 1, and then you use the arrow button, and you put a 10, and then you arrow over, and you'll punch in 35,000, parenthesis, 1.1 raised to the X minus 1. And you should get her earnings in the first 10 years of her job, $557,809.86. So a little over $500,000. So in the first 10 years, that's how much money she's earned. So can she probably pay off her student loans? Would that be something you want to look at when you're looking at your profession and how much your debt you're going to take? Like, for example, a lot of times we have teachers, we had a teacher who came and did some student teaching with us, and he was going to be a math teacher, and he was going to a private college. So one of our math teachers said, how dumb. Why would you go to a private school unless he's getting a full ride? Why would you pay to go to a private school to become a teacher? Why did he say that? Are teachers known for making a lot of money? But what do you know about private schools? They are a lot of money, right? They're a lot more expensive than public schools. So his take on it was, what an idiot, go to a state school because you're getting a teaching degree. When we hire teachers, we don't look if you came from a private or public college. Now, being a person who went to a private school, I could argue why my private school is better than your public school, but that's a whole other debate, right? But that would be something you'd think about. Maybe it's not worth going to the more expensive college when you're going to become something they're not going to hire you based on your private school education. If I'm going to be a doctor, is it important for me to go to undergrad at a private school that maybe is going to get me a better education in their mind and get me into that doctor program? Because I don't have to apply to be part of that program. So is there a private school maybe a better option? Maybe. I'm not saying it is or not, but maybe that's what I'd think about. So over this 10 years, I think this person can pay off their student loans, I bet. Right? Unless they live really crazy. Really nice house or something. Okay, number 2. A piece of machinery is valued at $80,000, depreciates $8,000 the first year, $7,500 the second year, and $7,000 the third year. How much did the car, apparently it's a car and a piece of machinery, depreciate in the 8th year? So, what's the pattern here? It's going down by 500. So would this be arithmetic or geometric? Arithmetic. We're losing $500 every time. So I'm going to use my arithmetic formula, and they asked for the 8th year. So I would say my value in the 8th year is A1 is how much it depreciated the first year. I wouldn't go with the 80,000 because we're looking at how much it's going to depreciate by the 8th year. So I'm going to say 8,000. And then if you look at your formula, it says plus n minus 1. So I'd say 8 minus 1. So I'm using, let me just highlight the formula I'm using. It's this one right here. And then I would say times the d. My common difference here we just said was negative 500, so I'm subtracting 500. So then I go through and I take 8,000 plus, it'd be 7 times the negative 500, so negative 3,500. So the value, the amount it's depreciated after 8 years would be $4,500. That's how much it'll depreciate in its 8th year. That's not how much it's depreciated total. That's just how much it would depreciate in the 8th year. If I wanted the total, I'd do a summation formula. I took 7 times negative 500. 8 minus 1. See, that's the nice thing about flipping. No one snickers when you ask a question to the computer. No one answers you either, but... Alright. Next one. KARP hears about KDUZ giving away Twins tickets and comes up with a giveaway of its own. KARP will give away $106.90 cash on the first day and $1,229.35 on the last day, adding the same dollar amount each day to the previous day's prize money for a total of $70,821.25. How much will be given away on the second and third day? It's a lot of info, right? Why do you think they'd be giving away $106.90? 106.9. Very creative on their part, isn't it? So, what do we know? What did they give us? Arithmetic, geometric, what do we got here? They're giving away the same dollar amount each day. Arithmetic or geometric? Arithmetic. So right now we can eliminate these formulas. Let's look at what they're giving us. They eventually want us to figure out what they're doing on the second and third day, right? So we have to look for terms 2 and 3. Isn't that what we're looking for? So what do we know? They gave us, what's this number right here? Is that how much they started with? That's how much what? That's how much they're giving away on the first day. But do we know how much they're giving away each day? We do? I think that's what we have to find, right? So is this really our A1? On the first day they gave away $106.90. And on the last day, how many days did they do this? Do we know? We don't. So we'll call this, on the last day, we'll call it AN maybe. We'll just say this is last day maybe, right here. Does that work? On the last day they gave away that much money. What else did they tell us? The total. So that'd be the sum. They gave us the sum here, right? So after all those days, we don't know how many days they did it, but after all those days, they had $70,821.25. So now, this is one, you'll notice, I don't know if you noticed this or not. Well, if you haven't watched any videos, you for sure didn't notice it. But this has, we have an extra formula here than we did the other day. So we're going to use that at one point. But let's use the one we learned. Can we use this summation formula right here? Do we know at least 3 of those 4 variables? We do, right? So we could use that to find n, because don't we need to find n, how much they gave away each day? So let's plug in what we know. I would say, so here's the, I'm just going to write out the formula I'm using because I'm going to get off this page in a second. now I'm going to plug in the sum we said is 70,821.25. N is what we don't know, right? We don't know how many days they did it. A1 is 106.90. AN is 1229.35. And then we'll divide that by 2. How's that looking so far? So far, so good. How do I solve this? Times by 2. So here I'd have, and then I'm going to go ahead and add these two numbers in the parentheses. I would have gotten 1336.25. Gary, because I added these numbers. And then I'll divide by the 1336.25. And I get my N, which tells me how many days we ran this competition, right? How many days did we do this in the radio? I get N to be 106. Go ahead, Gary. I don't think so. They can hear you if you yell, so I think when you watch the video, it's going to sound like I'm talking to my invisible friends. Yeah. Except I say your name. But I said Gary. Like I didn't say Johnny Drew. That was a dumb thing to ask. See, that'd be rude. Now, you guys, look how many days they ran this. Are they not creative as a radio station? How many days did this run? 106 on the radio station. That's 106.9. Come on, that's impressive, isn't it? You guys are not easy to impress. Oh, you're all impressed? Yes, good job. Good enthusiasm. So, is this answering my question? No. Why? Okay, so now what do I do? I know N. And what do I want to come up with? I want to know how many prizes will be given away on the second day. So do I know how much money they're adding to the pot every day? I don't. What's that variable? D. Good. Yep, you're right. D. That's D. Common difference. I don't know what's happening. If I was going to make this sequence, it's 106.9, and then they added some other number. I don't know what's happening from one to the rest. I just know that on the last day, they have this much money. So I didn't know how much they're adding. I need to know how much they add. So because isn't this what I'm looking for right here? I'm looking for my second and my third term, day 2 and 3. So we need to find D somehow. Which formula could we use for arithmetic to find D? Well, the bottom one is the sum. The top one, do we know all those variables? Well, all but one, don't we? Because didn't we just find N? So now if I use this formula right here, the nth term is A1 plus N minus 1 times D. I know that on my last day, the 106th day, we just found, right? I gave away 1229.35. We still know that our first day was 106.9. And since we know we had 106 days, we can plug all of that in. So I'm going to minus 106.9 from both sides. And I would have 1122.45. And then I take 106 minus 1 to get 105D. How are we doing so far? Really? And then I'm going to divide by 105. So now I'd find my D. $10.69. You guys, is this not the best radio? Come on, this is a good problem. It's pretty clever. Guess who came up with this problem? No, I'm normally this clever. Thank you for thinking that, but it was actually Mr. Rude. Who knew he was so clever? I know. So, the common difference, I want to give credit to him since this is a creative problem. $10.69 is what got added every day, so they're sticking with their 106.9 theme. So now, is this the answer to my question? No, they asked how much money will be given away on the second and third day. So I would take the 106.9 from the first day and I add 1069 to get a day 2 total of $117.59. And I'll label that day 2. And then I take, this is kind of our recursive formula here, isn't it? Then I take what they earned on that day, add another 1069, and I would get the amount for day 3 of 128.28. What do you think? And those totals are not as interesting. Okay. See, this is another moment to appreciate flipping because you don't have to stop for someone to do this. Or you could choose to do this on your own, couldn't you? Or fast forward. Okay, I'm going to let you rewatch that if you're stuck still. Are we okay with that? Does anyone actually know what time we get out of here? Today? Okay. On the back. This one we need a video for. But it says, a rubber ball dropped on a hard surface takes a sequence of vertical bounces. With each bounce, the ball loses 2/7 of its preceding height. That sounds technical, doesn't it? The ball is dropped from 21 feet. So let's think about what this looks like. Does it make sense that when you bounce a ball, it loses its height? Okay, Maddie, go over there. You need to be my ball catcher. We have to thank Mr. DeBrooker because every year on the day that I teach this lesson, I go borrow this bouncy ball from him. Exact same one every year. He has it in the same spot. So, bouncy ball, yes. If this is my height of 21 feet, do you see it? As I throw it to her, watch the pattern of the ball. What's happening? Besides the fact that I threw it crooked, you do see how it goes lower and lower and lower, right? The height, do we see how the height's going down? As I kept going, can you imagine what would happen with that ball? Okay, so there's our demo. Thanks, Maddie. I might need you again. We'll see. Maddie, it's not necessary to clap for yourself. So, here's my ball. I drop it, and basically it's going in this type of... Oh, let me do this a little better. In this type of pattern, yes? Does that kind of make sense? Have you done this in physics? Okay. So, my starting point was what? 21 feet. And they ask, the ball's dropped from 21 feet. What is the height? What height does it reach after the 4th bounce? So let's make a sequence here. What's the height after the 1st bounce? Oh, after the 1st bounce. Hold on. Shouldn't I say before the 1st bounce? That height of 21 doesn't matter? It matters. So my first sequence is actually not after the 1st bounce, is it? It's actually this 21 feet. So if I'm going to list my sequence, I'd have 21. And then what's the next height? 15. How'd you get 15, Maddie? You took 21 times 2/7. And minus that from 21. Yes. So 21 times 2/7. I wonder if you would take 21 times 5/7. What do you get when you take 21 times 5/7? You get 15. Tell me why you times by 5/7. That's what's remaining. If it loses 2/7 every time, how much is it gaining? Or keeping, I should say. How much is it keeping? 5/7. So wouldn't it really be 5/7 that's our R? So we're timesing by 5/7. So 21 times 5/7 is 15. Let's keep making the sequence. 15 times 5/7 is, I got 10.7. Does that sound right? And then 10.7 times 5/7 is 7.65. Now, in theory, if they asked me for after the fourth bounce, I'd maybe just make a sequence, wouldn't I? Would I go through all the work of doing all the formulas and all that junk when I could just do this really quick on my calculator? No, I wouldn't, right? So if you're on, let's say, your MCA test or your ACT, I'm not going to take the time to go through a formula if they ask for the fifth bounce. I could just make the sequence. Now, if they ask for the 25th bounce, would maybe a formula be faster? Yes, so we're going to learn the formula, but know when to use it and when not to. So it says, we're doing A, sorry. After its fourth bounce, so this is after 0 bounces. This is after 1 bounce, 2 bounces, 3 bounces. So let's actually use the formula here. And wouldn't we have a summation, or sorry, not a summation, would you have just the A4? So I'm going to say, how many terms am I going to be on the fourth bounce? What term number would that be? Is that my fourth term? After the fourth bounce? Why would it be my fifth term? Because the 21 is before the first bounce. Think about this. Right here, that 21, isn't that my first term? Have I bounced yet? No. So actually, my fourth bounce is my fifth term. Is that confusing? It should be, kind of, right? I mean, you have to think about that. But that's what it is. So I'm really looking for my fifth term here. So I'm going to say A5, my fifth term, equals, my first term is what? 21 times R. What's my rate? Or my ratio, I should say? 5/7. That's what it's losing, or what it's keeping, I should say. And then to the 5 minus 1. So when I plug that all in, I take 5/7 to the fourth power times 21, and I would have 5.47 feet. That's my answer to letter A. Now in letter B, it says find the total distance traveled when the ball hits the ground for the fifth time. So let's think of a picture here. I'm looking for this spot right here. So here's where the ball hits it for the first time, the second, the third, the fourth, and here's the fifth. I want to know the total distance traveled, don't I? So I need to know, I go here, I know this is 21, isn't it? What's this? And then what's this? Wait, what would this be? Why 15? Does that make sense? 15 has to be counted twice, and then this one would be 10.7. So this is a little harder than we'd think, right? And then so on. So I'm actually going to have to do 2 summations, because these need to be counted twice. All of them from here on need to be counted times 2, don't they? And how many times does this one need to be counted? Once. So we're going to do 2 different summations. The first one is going to be for my downs. Does that make sense? So all of my downs, I would do the summation from the first term, which is 21, right? All the way to which term? Well, 1, 2, let's see, 1, 2, 3, 4. Isn't there 5 of them? Because it's the fifth bounce, it's not bumping back up. So I'd have 5 up here. And then I use the same formula each time. So I'd have 21 to the 5/7 times n minus 1. This would give me the sum of all of my downs. Does that make sense? All of my downs. So when I figure this answer out, I'm going to add that to the sum of all of my ups. Someone's got to have a question so far. You could, right, Jacob, but we're learning the formula because what if they ask for after the 57th bounce? It would not be worth your time to do it. So I'm teaching you how to do it, but I also want to give you ones that are small enough so you can actually figure it out and check your answers. But if they ask, like on the test, guess what? I'll probably ask for the 276th term, because I'll know you need your formula, and you wouldn't have time. So now, is my summation formula the same for the ups? There's no 21 going up. So which term do I start with? 15, which is my second term. So this is the first time this has happened if you're caught up on videos. I say n equals 2. I'm not starting with the first term because 21 didn't have an up, or a down. Sorry, an up. 21 didn't have an up, so I'm not starting with that term. I'm starting with the second term, and I'm going through the fifth term. And then this formula is the same. It's giving 21 as the first term, but by saying n equals 2 here, I'm telling it not to use 21, aren't I? So now punch these two in your calculator, and we'll get the two totals, and we'll add them together, and that will be our total distance. Here's what I got. I'll approximate since I rounded. For my ups, I got 38.83, and for my downs, I got 59.83. Do those answers make sense? Who thinks they could come up with a smarter way to do this? Some of you, maybe. Would I have to do the blue? Could I have just done the red answer and doubled it? And then done what? Added 21? Would that make sense? That's smart thinking, right? If you think through it that way, that's fine. If you can't, I want to give you a process to use, which is what I'm teaching you here. But if you can do this in your head, that's okay. You should do as much in your head as you can, because if it makes sense to you in your head, that's the best way to do it, right? So now when I add these together, my total distance for after the fifth bounce is 98.67 feet. You're going to have a problem like this on accelerated math, and I'm just going to talk to you briefly about it. It's going to be a card problem. And it's going to say you start with 5 cards, let's say. And you're going to make 4 cuts. And so every time you cut the cards, you're going to cut them in half. How many cards will you have after your 17th cut? Well, let's say it'd be hard to cut it 17 times. Let's pick a smaller number. 5th cut, okay? If I start with 5 cards, what would I have next when I cut them all in half? I'd have 10 cards, wouldn't I? And when I cut those 10 cards in half, how many cards would I have? 20. So could you figure out the pattern here? Here's the tricky part when you do this in Excel math. After 4 cuts, let's say, after 4 cuts, how many cards would I have in this pattern? Well, 80? Is it 80? Or is it 40? Because 40 is my 4th number. I started with 5, and had I cut anything yet? I hadn't cut anything yet, had I? So even though they're saying, how many cards will you have after your 4th cut? That's really your 5th term. You'd have to think about it that way. So think about that when you get to that problem, okay? Similar to the bouncy ball one. All right, next up. KDUZ is planning to give away a total of 1,425 Twins tickets in the month of June. The station wants to increase the number of tickets given away each day by 3. How many should the station give away on the first day? 4,422 is our first estimate. How are Johnny's estimation skills? Horrible. Tell me why. Because he started almost 4 times higher than the total for the month. In your defense, you said what? Oh, I'm sorry. My bad. 1,422. I feel like the ballpark estimators at Park Elementary would do a better job of this, Johnny. 7? Okay, our other estimate's 7. 34, okay. 42. One more. We need 5. You can't give away 2.5 tickets? But we'll take it. If I take 1422, I better take 2.5. There we go. So now, tell me what we know. I think it's smart before you even decide what formula to use. Oh, can we decide if it's arithmetic or geometric? They want to increase the number of tickets given away each day by 3. Does that sound arithmetic or geometric? Arithmetic. They're adding 3 every day. Geometric is timesing. Subtracting is adding a negative. Okay? So I think it's arithmetic. So we can cross these out. Now, if they tell us that, what are they giving us there when they say they want to add the tickets 3 every day? What variable is that? D. So the common difference is 3. What else did they give us? Starting, ending. Total of 1425. Do we know how many days they're doing this? Oh, I think we do. The month of June is how many days? 30. I love how you're counting on your knuckles. So June has 30 days, so we know they're doing this for 30 days. So we had to think about that, didn't we? So on the 30th day, so I would say the 30th day's sum, right? Because it said total. I'm not going to use A, I'm going to use S. They've given away a total of 1,425 tickets. Do we know anything else? I wonder if they can hear me drinking coffee on this video. Now they hear me laughing through breath. What do we think? Is that all we know? Okay, what do we need to know? And what variable is that? We're looking for A1, aren't we? Okay, so let's see what formula I can use. I kind of want to use this formula, don't I? And do I know everything in that formula? I know N. Oh, I don't know AN though, do I? I know S, N, but I don't know AN. So can I use this formula? Not yet. I have two unknowns. I don't know AN and I don't know A1. I need to somehow find AN or A1. Jacob. Could I use the formula below it? Which one? Not this one, because I need both. Could I use this formula? Maybe this is why I gave you this formula, huh? For this exact problem. Do we know every variable in here except one of them? Yeah, we don't know which one. A1. We know N. This formula would give us A1, wouldn't it? So let's plug it in. S, so the 30th term, oh wait, sorry, we know that answer. It's 1425, isn't it? 1425 equals, do we know N? Yep, 30 times 2 times A1, which I don't know, right? Plus N minus 1, so 30 minus 1. It's for the previous term. A lot of times they use that. You'll see that when we study statistics. Next, try also with standard deviation. They take it away to make the estimates better. And there's a long thing I could give you on that, but I'm not going to do it on the video. But I'll tell you later, okay? So now, and then times by D. D is 3. And then divided by 2. So let's simplify this equation. 1425 equals, can I just reduce 15 and 30, or 20, I'm sorry, 30 and 2 here? Is it legal to do this? Yes, because it's multiplied, right? So I'd have 15, 2 times A1 plus, what's 29 times 3? 57? Nope. That was 19 times 3. 87? So now what should I do? Divided by 15, how about? What's 1425 divided by 15? 95 equals 2 times A1 plus 87. So I'm going to minus 87 from both sides. Looks like I have 8 equals 2 times A1. What's A1? 4. Who's the winner? Who was closest? Honestly, if we were going for accuracy, Keyser would win at 2.5, even though that's a ridiculous answer because you can't give away half a ticket. Good job. 7 was a reasonable and good estimate, yes. Huh? Is it? Nice. Okay. So now, did I answer the question? How much should the station give away on the first day? How many tickets? 4 tickets. So, the station. I know. Should give away 4 tickets on day 1. took 30 divided by 2? You could have times by 2 and then divided by 30. Maddie, and you get the same answer. One more time? Really? Okay. Last couple are recursive formula. Now, I hate the recursive formula kind of because it's a lot harder than it has to look. So this is actually taken off an MCA test, well, a practice test, because it would be illegal for me to take something off an actual MCA test, or for me to even look at them. But this is an actual question off the practice exam they give you. Okay, so this is where you'd see recursive, and I'm assuming the ACT would be similar than if you see it. Recursive is super easy, so I don't want you to get it wrong because of the notation. It looks confusing because of the way they word it. See this? But it's not. So here's what it says. Dr. Franklin begins an experiment with 100 bacteria in a container. She finds that the number of bacteria present at any given time is modeled by the following recursive formula. So they're saying at the start, she started with 100 bacteria. Isn't that what A0 means? So we started with 100. And then what's happening is it's doubling. Is that what it looks like here? Where n is the number of hours after the beginning of the experiment, how many bacteria are present after 5 hours from the beginning? So after 5 hours, how many bacteria are present? So when we start, we have 100. And I'm not going to make you write this with recursive as long as you can figure out the answer. That's all I care about here, because I think that's what you would do in the real world. Right? You're not going to write a formula if you don't have to. So after 1 hour, how many bacteria do we have? 200. As long as you realize this is after 1 hour, you're fine. Some students think that 1 hour is 100. Do we see why that's not true? Yes, you have to think about that. So then after 2 hours, how many bacteria do we have? And 3 hours? And 4 hours. So after 4 hours, is that what they were looking for? 5. One more time. 3,200. After 5 hours, so here's my second, my third, my fourth, my fifth hour, I would have 3,200 bacteria, and that'd be the multiple choice answer you would pick. Really what you need to be able to understand is this, when they write it like this, this is saying you take 2 times the previous number. That's all that's telling you. As long as you can read that, you'll come up with those answers all the time, because they're kind of easy after that, aren't they? So now let's apply that to the next one. Find the first 5 terms of each sequence. I'm going to let you just list the 5 terms. So the first term for the A is what? 4. What do I do to find the next term? I times it by 3 and then subtract 6. Does everyone, can you read that? Times by 3, subtract 6. That's what that's saying. Notice they didn't use n minus 1 here. They used n and then n plus 1. So they're saying the previous term and the next term, kind of, or the current term and the next term. So times this by 3, and then subtract 6. What do I get for my next term? Someone said it, I think. 6. So you list all 5 terms. Do that quickly for me. Sorry. Do we have an answer yet? What is it? No, you have to list all 5 terms. They asked for a total, they asked you to list them. What comes after 6? 12, then what? And then, good. Everyone feels good about that? So every time to get from 1. Now, the next one, B then, they give us, my smartboard's off here. So it says A1 is, the first term is 4, the next term is -3. So it's 4 and then -3. To find the next term, what do we think we have to do? What do you think that's saying there? That's a harder one to read, right? What do you think they're telling us to do? It says, okay, so here it says to find n plus 2, I would take n plus 1. Which term is n plus 1? Isn't that this one right here? The one before that? So -3, and I add 2 times an, which would be the previous term there. And that would be a very complicated one to give you, I think. So always I would take the term before it and then add it to the term before that times 2 every time. So to do that here, I would take -3 plus 2 times 4, which would give me 5. And then how do I find the next term? I take 5 plus -3 times 2. So I'd go 5 plus 2 times -3. And that would give me -1. Then I take -1 plus 2 times 5. And that would give me 9. Can you see how recursive can get really confusing? Yeah, I think that's kind of the worst you'd ever see. I don't think on your ACT or your MCA you'll get ones that hard. I think they just want to know that you know the notation. So you'll get more like this letter A here. But I want to make you think too. Any questions? All right. Homework for that then is a worksheet I'm going to give you and some objectives. If you have any questions, feel free to talk to me tomorrow in class.